Hello, this is a review of homework 7, problem 3. This is problem 5.008, centroid of a semicircular area. So locate the centroid of the plane area shown if r equals 42 inches. And in the problem here, we can see that there is a semicircular area of radius r, and then there is a small rectangular cutout that is 16 by 20 inches. So, and we're trying to figure out what the centroid of the plane is. So once again, first thing I would do, I would just, any information the problem gives me, I would write down. So in this case, it's just that r equals 42 inches, and that we should also note these two, the two lengths that are given, so 16 and 20. After we have all of that information, we can start finding the centroid. A nice note here is that these are common shapes. So going into the lecture notes, there are common formulas for these that we can use instead of having to try and figure out what exactly, or doing it by like directly integrating or something. So with that in mind, we want to make this as easy for ourselves as possible. So when I'm looking at this diagram, I can actually see two shapes. So I see this whole semicircular area, and then separately, I can look at this little square cutout here, or rectangular cutout. So what what we're going to try and do is we're going to find that we're just going to treat the semicircle as a positive area. So we're going to treat that as positive area. And then we're just going to treat this square here as negative area. And that'll allow us to create or find those centroids properly. So with all that in mind, I would advise to pause here if you want to try it, and just see if you can go through taking those, finding the areas for each and the centroids for each. So like I mentioned earlier, we have area 1, which is that 1/2 pi r squared, and then the x centroid is just in the middle because it's symmetrical about the y-axis. And then for our y centroid, once again, this is in that table. So that is 4r divided by 3 pi. And then for for your little square here, so your shape 2, that area is just the area of a rectangle, so length times width. And then this shape will have the x and y just in the middle of the part because it is, once again, assuming if we were to put an axis in the middle of this, it would be symmetric about all of them. So with that knowledge, we can start developing a little table that just organizes our information. So what I'll do is I'll find the area of A for both regions 1 and 2, then I'll also find the centroids for each of those individually. In doing so, gets us this table here. So we have the areas of each segment, the x and y centroids, and we also need to denote the total area. And the reason we need to do that is because if we look to the right here, we have these two equations that we're going to use to solve, right? So we're going to sum up all the individual centroids in their area, and then we're going to divide by the total area to figure out what the centroid is for the entire plane area. Same for y. So when doing that, what we'll get is, I'll just take a sec to do that math. So for example, for the x direction, what we'd have is we would just have a1 times x bar 1 plus a2 times x bar 2. And when you do that, what you'll get is you'll get a result of 1.18 inches, and then doing a similar process for y, you'll get 19.92 inches.